So in this video, we will talk about various wireless sensor network protocols. So we'll see what are the various protocols we are using in case of wireless sensor network. So first protocol is the sensor management protocol. It provides the software operations needed to perform administrative tasks such as moving sensor nodes, turning them on and off. So sensor management protocol is very important to carry out the various administrative tasks required in case of wireless sensor node. Now next protocol is the sensor query and data dissemination protocol. This protocol provides user applications with interfaces to issue and respond to the queries. It uses sensor query and tasking language, which is called as SQTL. So this protocol is important for the data communication. For that, it utilizes SQTL to share data from the wireless sensor node to the remote server. Now another protocol is direct diffusion. So direct diffusion is a method of data dissemination in distributed sensing scenarios. Here, the data generated by sensor nodes are identified by their attribute value pair. So in this case, what will happen that the sync nodes means the nodes which are requesting data from the source. So these sync nodes will send out their interest into the network. So interest means they are interested to receive the data. Now this interest will be floated in the network. Now the data generated by the source nodes that match the interest. So the interest which has been initiated by the sync nodes, if that interest matches with the interest of the source, then the data flow happens towards the sync. So here the attribute value pair, that is your interest and data and the flow and the data, will be the prime key value pairs for data transmission. Now intermediate nodes which are responsible to forward the data, these intermediate nodes will have the capability of caching and transforming such kind of data. Now next one is the sensor MAC, that is called SMAC. So SMAC is the MAC protocol designed for especially the wireless sensor network. MAC is nothing but media access control. So this is your data link layer based protocol which we generally use in computers and Wi-Fi. So SMAC is the MAC layer level protocol which is specifically designed for wireless sensor network. Now the characteristics of the sensor networks, that is the energy conservation and the self configurations, which are the very important components of wireless sensor network. So these sensor networks and the applications make the SMAC different from traditional wireless MAC which we use in Wi-Fi. So it is given in IEEE 802.11 set of protocols. So this SMAC is different from our traditional wireless MAC in terms of the important attributes, that is energy conservation and self configuration. Now next is IEEE 802.15.4, which is widely utilized in wireless sensor network data communication. So let's see in detail about the 802.15.4 protocol. So IEEE 802.15.4 is the IEEE standard which offers physical as well as media access control layers for low cost, low speed, low power wireless personal area networks. which is commonly known as WPAN. WPAN means Wireless Personal Area Network. Now, what is the history of the development of 802.15.4? It is the combination of two standard groups. One is Zigbee Alliance and another is IEEE 802 Working Group 15. Then the Task Group 4 as a subgroup formed in 802 Working Group 15, which was formed in 2000 December, was given the task to develop the protocol for low rate wireless personal area network, which we commonly know as WPAN. So PAN is for personal area network and wireless personal area network will be called as WPAN. Here the focus is only on the physical and MAC layer specifications. It provides a standard with ultra low complexity, cost and power for low data rate. So when you compare with the standard MAC, the 802.15.4 is having reduced functionalities. So it will contain only those functionalities which are extremely important for the data communication by wireless sensor nodes. So it provides with ultra low complexity, cost and power for low data rate. Wireless connectivity among fixed, portable and moving devices are being taken up by the IEEE 802.15.4 protocol. Now, what are the various approaches carried out in 802.15.4 for low power? So, in order to achieve the low power and low cost goals established by IEEE 802.15.4, the following approaches are taken. So first is reduce the amount of data being transmitted. So that's why the data packet in 802.15.4 is smaller in size so that the amount of energy required to transmit the data is less. Reduce the transceiver duty cycle and frequency of data transmission, means you will send data at very low frequency or maybe sometimes in few minutes one data packet is being sent so that you can optimize the energy consumption. Then reduce the frame overhead. That's why in 802.15.4 we talk about only media access control as well as the physical layer control. So when you have less layers means the frame overhead will also be less, and in that case the amount of data to be transmitted will also be less. Then reduce the complexity, means in case of 802.15.4 the complexity of MAC layer is reduced with minimal required functionalities. Reduce the range. So if you want to send data over a longer distance means you need more power, and since the power is the constraint in wireless sensor nodes, the range of data transmission is reduced so that the energy can be conserved or the less energy can be utilized in data transmission. Implement strict power management mechanism, because this is the most important component in wireless sensor network. That's why the wireless sensor nodes are designed in such a way that they send the data to the nearest neighbor and immediately they power down themselves, or they may go in the sleep mode. So that's why the wireless sensor nodes have the capability to sleep as much as possible. Now let's talk about the various devices. So in the IEEE 802.15.4 we will have two different types of devices. One is full function device, which we call it as FFD. So this FFD will support any topology. It is capable to act as a PAN coordinator because it will be mostly powered device. So having the availability of continuous power, these devices act as a PAN coordinator. So here the principal coordinator of PAN will be responsible to receive the data from nearby devices, consolidate the data, and then forward it to the server. So principal coordinator of PAN, that is PAN coordinator, will be exactly one in one network, because it will act as a main controller for that particular wireless sensor network. It has a capability to talk to any other device which is located in its environment. It implements the complete protocol set because this is full functional device. So most of the time it will have full functional MAC layer rather than having the reduced MAC layer in the full functional device. So FFD with network device functionalities provide coordination and other services to the network. So this will also have the capability to implement the full stack of TCP/IP, because these devices are generally responsible to consolidate the data from other reduced function devices, consolidate the data, and then send data to the server. So for sending the data to the server, these devices have the capability of full network functionality, so that the data can be transmitted to the remote servers easily. Then second type of device is reduced function device. This reduced function device is essentially with the reduced MAC services, where the reduced protocol set is implemented. The implementation is very simple because these are designed for low power consumptions. These cannot become PAN coordinator because most of the time these devices send the data and sleep. So their availability is very limited, and because of that they cannot act as a PAN coordinator. These type of devices are limited to leaves in a more complex topology. So leaf means the pen coordinator will act as a central controller, and from that central controller you will see multiple leaves coming out, where the end nodes of the leaves will be the reduced function devices, because these devices have the major role of data acquisition from the field and then share the data with the PAN coordinator.